Today we're going to take a look at composite functions where a variable within a function ends up being another function. So all you do is plug the function in for the variable and simplify the problem. For problem 1 we have g of f of x, where g of x is the square root of x minus 2. So for x we have f of x in its place, and that's just going to equal the square root of x squared plus x minus 2. For number 2 we have h of f of x. H is just 3 over x, so that'd be 3 over f of x, and that's just going to equal 3 over x squared plus x. Number 3 is f of g of x. So f of x is x squared plus x, so we have g of x squared plus g of x. And when you plug that in, you get square root of x minus 2 quantity squared plus the square root of x minus 2. And that just gives you x minus 2 plus the square root of x minus 2. Number 4 is g of h of x. So g is the square root of x minus 2. So it's going to be h of x minus 2 under the square root. And then we could plug in 3 over x for that. So you have the square root of 3 over x minus 2. And then we'll want to simplify under the square root. So you have 3 minus 2x all over x and all under the square root. And we'll call it good there. No need to rationalize. Alright, number 5 is going to get a little trickier. So we have f of x. So we're plugging the function f of x into itself. So you have f of x squared plus f of x. And that's going to equal x squared plus x quantity squared plus x squared plus x. So then you got to multiply these out. I'll just write it so it's easier to read. You have x squared plus x times x squared plus x plus x squared plus x. So you multiply these together, you have x squared times x squared is x to the 4th, x squared times x is x cubed, x times x squared is x cubed, and then x times x is x squared plus x squared plus x. And then we just add these all together. So we have x to the 4th plus 2x cubed plus 2x squared plus x. For number 6, we have h of x. So it's going to be 3 over h of x, which equals 3 divided by 3 over x. So that's going to be the same thing as saying 3 over 1 times x over 3, because when you're dividing by a fraction you can reciprocate it or you flip it, and the 3's are going to divide out, so that's just going to equal x. Alright, for number 7, the last problem, it's going to look a little trickier. We have f of g of h of x. So for f of x you're going to put g of h of x inside the function, so in this case x squared plus x. So you have g of h of x quantity squared plus g of h of x. And then for g of h of x you have square root of x minus 2, where it's h of x. So I'll write all these steps out so you can see them. So you have h of x minus 2 quantity squared plus g of h of x, which is just h of x minus 2 under the square root. And then h of x is just 3 over x. So 3 over x minus 2 all under square root, quantity squared, plus the square root of 3 over x minus 2. And then when you square the square root, it goes away. So you have 3 over x minus 2 plus the square root of 3 over x minus 2. Let's simplify the fractions a little bit. So 3 minus 2x over x plus the square root of 3 minus 2x over x. So if you want to simplify this even further, just to turn this into one fraction, you can multiply this term by the square root of x over the square root of x, because x over here is just the square root of x squared. So when you do that, you get 3 minus 2x over x plus square root of x times square root of 3 minus 2x, 3x minus 2x squared under the square root, and you get an x here on the denominator, so you can actually just put all of these terms over x.